The next two videos are going to be on different methods for preparing amines. In this video, we'll review some of the methods we've learned already, and then we'll learn one new technique, reductive amination. Okay, so one method for making amines from alkyl halides is if I start with a primary alkyl halide, I can react that with sodium cyanide, and that will undergo an SN2 reaction where the halogen has been replaced by our cyano group. I can then reduce that with lithium aluminum hydride to give me my amine. And what's important about this method is that it expands the carbon skeleton by one carbon atom. All right, back in the carboxylic acid derivatives chapter, we learned how to make amides from carboxylic acids, and we also learned how to make amines from amides. And so while the sort of heading of this slide is preparing amines from carboxylic acids, I mean, this is really true for acid halides or amides as well. If I have a carboxylic acid, I can convert that into the acid halide. Usually we do an acid chloride with SOCl2. I can then treat that with excess ammonia to give me the amide, and then I can reduce that with lithium aluminum hydride to give me the amine. So really, this slide should maybe be titled, How to Prepare an Amine from Carboxylic Acid Derivatives. I can do it from a carboxylic acid, I can do it from an acid chloride, or I can get there from an amide. It just depends on how many steps I need to use. The difference between this method and the previous one is this does not change the length of the carbon skeleton. A third method we learned about preparing amines is when we were talking about electrophilic aromatic substitution reactions. And so we know that we can nitrate the benzene ring by using nitric acid and sulfuric acid, and then we can reduce that nitro group into amine. When we did this previously, the reagents that we learned to do the reduction were either iron or zinc and HCl, followed up in a second step by using sodium hydroxide, but you can see there are other reagents we can use. We can use tin 2 chloride, or we could use H2 with a platinum catalyst. Okay, so let's look at a new method for preparing amines, and it's called reductive amination. And I can't tell you how many times I have to restart this recording because I'm saying animation. If I do it again, I'm just going to keep powering through, but I'll try to say amination. And so in reductive amination, a ketone or aldehyde is first converted into an imine, and then I can reduce that with a number of different reducing agents that we'll talk about. One of them would be with hydrogen gas and a platinum catalyst, but the end result is converting that aldehyde or ketone into an amine. Now, a number of different reducing agents can be used to convert the imine into the amine. One of the more common ones is sodium cyanoborohydride. And so this is closely related to sodium borohydride, but we've replaced one of the hydrogens with a cyano group. The advantage of using this particular reducing agent is that it's fairly selective for imines, and it won't react with ketones and aldehydes. And so we can sort of do the whole reaction at once, and we don't have to worry about doing it in multiple steps. If we just use sodium borohydride, it would reduce the aldehydes and the ketones before we had a chance to turn them into the imines if I tried to do it all in one step. So the advantage of the sodium cyanoborohydride is that I can add the reagents to convert it to the imine and to do the reduction into the reaction flask all at the same time. So this is the reducing agent that I'll typically use when I want to use this method for making amines. Now, another useful thing for this reductive amination is not only does this work when I convert my aldehyde or ketone into an imine by reacting with ammonia or a primary amine, but if I turn my aldehyde or ketone into an enamine by reacting with a secondary amine, I can still get the amine at the end. So we can either react our aldehyde or ketone with ammonia to get a primary amine. We can react it with a primary amine to convert it into a secondary amine, or we can react our aldehyde or ketone with a secondary amine. It'll go through the N-amine, but in the end result, I'll get a tertiary amine. And this is particularly useful because all of the preparation techniques that we're going to learn in the next video are good for making primary amines, but if I want a secondary amine, reductive amination, or if I want a secondary or a tertiary amine, reductive amination may be the way to go. Okay, finally, let's finish this video off with an example. Let's say I wanted to make this compound through reductive amination. Well, there are actually two different pathways that I could go. I could either have this group come from the aldehyde or the ketone, and then the rest of it come from the amine, or I could have this group come from the aldehyde or ketone, and then use this group to replace the aldehyde or ketone with the amine. So those two different strategies. So if I imagine on the left-hand side, I'm going to have this be the aldehyde in this case that I'm starting with. So to do reductive amination, I need an acid catalyst, and then the amine that I'm going to use to turn this into the imine. And so in that case, it's going to be that compound, and then I need the reducing agent. And I don't need 1 and 2. The advantage of the reductive amination in using this particular reducing agent is that I can do it all together. Or I can come from the other direction and I can say, well, no, let me start with this is my aldehyde, and then I would need to react it with this amine, the acid catalyst, and my reducing agent. All right, so that's it for this video. The next video also on preparation of amines, but largely for making primary amines.